Okay. Okay. Good evening. Sorry, good morning. Can you hear me? Yes. Yeah. Last. Yeah. We in the extra class last uh, Friday. No. We discussed about mechanical properties of matters. The basics of mechanical properties of matters. Mechanical properties of matters. Okay. It's a very simple lesson actually. Mechanical properties of matters. Okay, I will revise what we discussed Friday again, and I given homework now. Yes. Okay, I told mechanical properties. Actually, before that, what's the meaning of matters? Matters mean any substance that take space in the surrounding. Any substance that takes space in the surrounding that we called as matters. What are the examples for matters? Types of matters: solid, liquid, and gases. Remember, solids, liquid, and gases are the matters. Solid, liquid, and gases are the matters. Any substance that take space in the surrounding. Space substance matters. They are mainly three physical states: solid, liquid, and gases. Okay, now what is the meaning of physical properties? Not physical, mechanical properties. Okay, I told in properties of matters mainly three types. Main three types. Properties of matters: physical and chemical properties, electrical, electronics, and magnetic properties. Finally, mechanical properties. I told in this lesson we are discussing about mechanical properties, only mechanical properties. Mechanical properties. Anyone can remember what's the meaning of mechanical properties? Can anyone remember? What's the meaning of mechanical properties? Mechanical properties. Last lesson we discussed about mechanical energy. It's an energy type due to object position or object motion. But today we are discussing about mechanical properties, mechanical characteristics. Okay, what are the meaning of mechanical properties? Do you remember? This definition is important. Mechanical properties. Yes. When we apply external force on any object, how this object responds to this how this object responds and how this object behave for this external force. Yes, very good. That's a definition. When we apply external force on any object, simply remember the concept. When you apply external force on any object, think external force on any object, how this object behave due to this external force and how this object responds to this external force we called as the mechanical properties. Good. Okay, mechanical properties. What are the examples for mechanical properties? I told several number of mechanical properties. Many number of mechanical properties. I told elasticity, plasticity or inelasticity, What else? Ductility, malleability, toughness, toughness. What else? Hardness, uh, toughness, hardness, and get your tooth. I have got several names. Ductility, malleability, brittleness. Yes, brittleness. Brittleness, toughness, hardness, strength. Yes, strength, strength. Okay, so on. They are the mechanical properties. Mechanical properties. Mechanical properties. Main type of mechanical properties. How this, when we apply external force on any object, how these object behave and how this object responds to this external force. That's the meaning of mechanical properties, and they are the responses. Elasticity, inelasticity, ductility, malleability, toughness, hardness, brittleness, strength. Okay, they are the responses. Okay, now I told in this lesson we are mainly discussed about elasticity and inelasticity. They are the main type of mechanical properties. They are the main responses. They are the main responses. Okay, now what is the meaning of this elasticity? Do you remember? Elasticity. What's the meaning of elasticity? What's the meaning of elasticity? Elasticity. I told rubber is a elastic matter. When we apply external force, it's deforming, and when it is released, again come to the original position. When we apply external force, simply remember the concept. When the elasticity mean when we apply external force on any object, it's deforming. Now it is deforming. But if it is released, if I release this external force, again it's come to original position, original length. Okay, understood? That's the meaning of elasticity. That's the meaning of elasticity. Not only deforming, okay? Not only deforming. When we apply external force, it's not only deforming, it's not the elasticity. When it is released, it's returned to original length or original shape. Understood, Mariam? Okay, that's the meaning of elasticity. Yeah, that we discussed last day. That's the meaning of elasticity. Elasticity. Now, what's the meaning of inelasticity? Inelasticity. What's the meaning of inelasticity? The opposite side. When we apply external force like this, when we apply external force, deforming, but if it is released, no again come to original position. Understood? I'm gonna make a hold that, but it is not come to original position. Like it permanently deformed. Permanently deformed. Okay, that's the meaning of inelasticity. Inelasticity means when we apply external force, it's deforming same as elastic object, but when I release it, it's not recovered again. It's not recovered again to original position. Okay, that's the meaning of inelasticity. Okay, do you remember examples for elasticity substance? Example? Tell me example. Example for elastic substance. Okay, today we can complete 90% of this lesson. That's it. That's a very simple and short lesson. Okay, what are the examples for elastic substance? Natural rubber. Natural rubber is a elastic substance. What else? Natural rubber. Natural rubber. Sade, what else? Yes. natural woods, natural woods. Okay, example, natural woods are elastic. Now think it is a plant. Plants, this is a branch of plants. Branch එකක් කියන අත්තක්. හරිද? මෙහෙම තියෙන branch එකක්. When you apply external force, what happen? It's deforming. අපි මෙහෙම ඇද්දොත් මොකද වෙන්නේ? Deforming. But if I release, again come to original shape, right? Original position. Okay, that's why we call natural woods are elastic. Understood? I think you have experience. මෙහෙම අත්තක් තියෙනවා. අපි මෙහෙම ඇදලා ආය අතරියත් මොකද වෙන්නේ? It's come to original position. Yeah, that's why it's not breaking, right? අපි ගොඩාක් ඇද්දොත් break වෙනවා, but in certain range it is elastic. Okay, rubber also not unlimited elasticity. The elasticity always working in a particular range. Okay, example, then අපි මෙහෙම මේක අපි unlimited ඇද්දොත් it's breakdown. The elasticity act on in a certain range only. The natural wood is a good elastic substance. Good elastic substance. Okay, what else? Glass. Yes, glasses also, but their elasticity range is very limited. Glasses, but they are elastic. In a small range, glasses elastic. What else? What else? Metals like ions, metals, they are elastic substance. Metals, and some plastics. Not all plastics types. Some types of plastics are elastic. Some type of plastic, they are elastic. Okay, about plastics, we're fully discussing about in polymer lesson. Polypropylene, polyethylene, polyvinyl chloride, PVC, all type of plastics and polymers we are discussing in our polymer lesson. We have separate lesson. Okay, what are the inelastic substance? They are permanently deforming. What are the inelastic substance? Inelastic. What are the inelastic substance? Example. Yeah, clay is a good inelastic substance. Clay. What else? Paper. What else? Cardboards. What else? Some plastics types. Okay, they are the elastics and inelastic differences and example. Any doubt? That we discussed, but I am revising. So they are very important. That's the basic of the lesson. No doubt, right? Okay. Elasticity and inelasticity. Okay. When we're discussing about elasticity and inelasticity, we need basic fundamental concept. Okay, the first fundamental concept, the first one, extension. Okay, what's the meaning of extension? That's simple E. What's the meaning of extension? Okay, it is very simple. When we apply external force, it is deforming the increasing length. When we apply external force, F, the increasing length, the delta L is the extension. think it is L1 is the initial length and L2 is the new length. L2 is the final length. Then the E equal L2 minus L1. That means final length minus initial length. The extension equal delta L. Extension equal delta L. Extension equal delta L. Delta L mean length difference. Length difference. Okay, that's the meaning of extension. When we apply external force on any elastic object or elastic substance, increasing or decreasing length. Both increasing end pull and decreasing end pull, both extension. Okay, what's the meaning of decreasing? Now increasing, okay, increasing mean is increasing, right? Length increasing amount, extension. What's the meaning of decreasing? Think on this rubber cube, the force applied into this direction. Now what happened? Length increasing or decreasing? Length decreasing, right? That we call as compressive force. Compressive force. Compressive force. Due to compressive force, length decreasing also, it is same name, extension. Then when we apply external force on any elastic object, increasing or decreasing length is the extension. Remember? You met? Tirul? මම නිකන් කියන්නේ මම කරා මේවා. Okay, second concept. What's the second concept? Strain. Strain means sigma. Okay, what's the meaning of strain? The strain mean relevant to the initial length, the increasing length, or that mean extension, increasing or decreasing length, extension, relevant to the initial length. This is relevant to the initial length. Actually, the ratio, the ratio between this extension and the initial length is we call the strain is a measure of relation of extension relevant to the initial length. Actually, the strain equal extension mean delta L, extension over, that's ratio, simply that's ratio, extension over initial length. Strain equal extension E over initial length L1. What's the unit? Meter to meter cancel out. No unit for strain. Remember, extension unit meters. Extension measured by meters because it's the length, increasing or decreasing length. Okay, that's the summary of strain. Okay, finally, I discussed about stress. Third one, stress. This is a symbol. Stress. Okay, what's the meaning of stress? The definition, you met? What's the definition of you met? Sorry, stress. Definition of stress. Not you. You met? Yes, good, Priyanka. Not external force, perpendicular external force per unit area is the stress. Perpendicular external force. In the tube given as external force, right? Please correct this. Wait. Yeah, it should be perpendicular external force. Yeah, internal or external force, no problem. Perpendicular. Perpendicular, internal or external, both okay. Internal or external. Force per unit area generated inside of a body when external force act on it, yes, that we called as a yes, good you get. Good. Okay, that's the meaning of stress. Stress. Normally, the simply pressure, right? The pressure act on a yeah pressure. This is a symbol that we call as sigma tamame. Up make it කියනවා wait, it has a name. It has yeah, both sigma. It's capital and simple. That's the difference. Calling a capital, may simple. Both sigma. Both sigma. May sigma. They are Greek letters. They are not asking that for. You can use in the exam. The name is not asked. Right? Name these are symbol. Okay. Stress equal perpendicular force act on any elastic object divided by surface area. Divided by surface area. Stress equal perpendicular force perpendicular applied force divided by the area, unit area. That's the meaning of stress. The perpendicular external force act on a unit area of elastic object that we called as stress. Okay, stress equals sigma perpendicular force F over A. F over A. This is the equation. Okay, what's the unit? Nm minus 2O Pascal. Same as pressure. Same as pressure. Same as pressure. Actually, pressure act on a elastic object. Pressure act on elastic object. That's a stress. Stress. Okay, I told stress mainly two types. Stress mainly two types. What are the types? Stress mainly two types. Tensile stress and tensile stress and compressive stress. Compressive stress. Compressive stress. Okay, what's the meaning? What's the difference? Tensile stress always increase increase the length of the elastic object. Compressive stress always decrease the length of the elastic object. Okay, tensile stress always acts due to tensile force or tension force. Act due to tension force. Tension force mean like this. Tension force. Tension force. Tension force like this. If you got this type rubber strain, tension force increase in the length. Increase in the length. Tension forces. Compressive force, sorry, compressive stress always act due to compress force. Compress force mean compress force. Compress force mean like this. Compression. The length decrease. Okay, that's the difference. Okay, compressive stress and tensile stress. It's mainly two types, tensile stress and compressive stress. Okay, that's the lesson we discussed last day, and now we can go to homework. Okay. Okay, what's the first answer? 5 meter length and okay, this is a question. 50 Newton. 5 meter initial length. 5 meter length and 0.2 square meter. The cross section area 0.2 square meter. Square meter. Cross section area rubber string is given in the figure. When applying an external force, the rubber string length increased up to 5.002 centimeter. Sorry, meter. 5.002. Okay, up to this level increase. Okay, the total length, total final length 5.002 meters. Okay, that's a full question. Okay, it is given in the group. You can find this question in the group. Okay, first one. Calculate the extension of rubber string. Okay, first one, very simple. Calculate the extension on the rubber string. What's the meaning of the extension? The increasing or decreasing length. Now, what is the type of force? It is a tension force. Therefore, length increasing. Okay, the increasing length is the extension. Simple E equal 5 minus 5.0, 5 minus 5.002 meters. The answer is 0.002 meters. Give me a second. Okay. Okay, sorry. Question number 2. The strain, right? Calculate the strain act on the stream. Okay, how to calculate the strain? Strain means capital sigma. Strain equal extension over initial length. What is extension? 0.002 meters divided by what is the initial length? 5 meters. Meter to meter cancel out. What's the answer? 0.002 over 5. 0.0004. 0.0004. No units, only the value. Okay, question number 3. Write down the type of stress applied on the string. Definitely it is tensile stress because length increasing due to tension force. Tensile stress. Tensile stress. Tensile stress. Final one. Calculate the value of third part answer. That means the value of tensile stress. Simple sigma equal perpendicular force divided by cross section area. What's the perpendicular force? It is 50 Newton. 50 Newton over cross section area 0.2 square meter. 50 over 0.2, that means 500 over 2, 250 Nm minus 2 O Pascal. Okay, that's the answer for homework question. Okay. Okay, complete. Pandit. Okay. Now this is February. No? Your what is the exam? Exam we have very limited time. But we have now we are doing 7th lesson. After this lesson, you have another 18 lessons. 18 lessons and you have another 18 months. මාස 18ක් වගේ තමයි තියෙන්නේ. Yeah, approximately 18 months. Okay, comparatively the time period, the workload is huge You have huge workload within limited time. But don't think the 18 months is a very long time. It's a very short time. Then syllabus you have huge workload within this 18 months. Okay, therefore now you have to start consistently working, every day working. Every day you have to take a few hours every day. Think 4 hours. If you got 4 hours every day, you have to spend this time for your academic works. If you continue this working process in final few months, it will be very simple, very easy to manage and ready for the exam. හරිද? හැමදාම වැඩ කරගෙන යන්න තියෙනවා. එම නිදි මරාගෙන වැඩ කරන්න ඕනේ නැහැ මේ දවස්. මේ කාලේ. කරන්න ඕනේ හැමදාම every day you have to work your comfortable time. You can prepare your time. Which slot you are working. Comfortable zone continuously, the consistency is a very important thing. Then very simply, very easily you can get a good rank with good result. Now measurements, forces, now you can practice those lessons. They are very important lessons. Actually, now we are doing bit simple lessons. Previous lessons is important. Work energy power, what else? Trigonometry easy. Force especially, you have to practice again. Now you can find difficult advanced question in home past papers, and you can practice. Okay, in exam papers, I will give you questions. If not, you can find. You have all past papers. Better to get all past paper printouts. And I have uploaded in website all mark scheme as well. You can download them and you can practice and check yourself. Okay, that's the method. Continuously, you have to work on this. Every day working is very important with consistency. You can ගොඩක් tension ගන්න නැතුව consistently your comfortable zone, comfortable time working is the best thing. All right, let's move into question number 2. Okay, question number 2. Okay, if you got a concrete beam or concrete breach or whatever concrete beam, hari mono hari concrete වලින් හදපු එකක්, is it elastic or not? Concrete structure, is it elastic or not? What do you think? Elastic or not? In a very small range, they are elastic. That's why I think you know some bits are moving very small range. The reason they are small range, only in a small range they are elastic. That's why they can retain more stress. They can retain more stress due to this elasticity. Okay, think this is a concrete beam in a bridge, 15,000 newtons. Okay, write down the question. 20 centimeter radius and 300 centimeter height. Concrete beam is given in the figure. Given in the figure. Given in the figure. Concrete beam in a bridge. Bridge, Palamaka. Bridge is given in the figure. Okay, now force is compressive force. Due to compressive force, the length decreases. Okay, what is the extension now? What's extension? First part. Extension equal. Okay, do you need more time? Okay, I'll give you one moment. Okay, complete. Okay, first one. Extension. What's extension? Yeah, initially it is 390 centimeters. After apply this force, it's decreased up to 389.5. 390 centimeter minus 389.5 centimeters. Okay, now what is extension? 0.5 centimeters. But I told the standard unit is not centimeters. Standard unit is not centimeter. Answer 0.005 meters. 0.005 meters. Second one. The strain. What's the strain? The ratio between extension and initial length. The extension 0.005 meters. The strain, initial length 390 centimeters. 390 centimeters means 3.9 meters. Meter to meter cancel out. What's the answer? What is the strain? It's a very small value. The meaning relevant to the initial length, the increase in length, the extension is a very small value. That's why the strain is very small value. 0.00128. 0.00128. No units. The reason it's a very small value, the reason relevant to the initial length, the increase in length is a very small value. Making the increase in length is a very small value relevant to initial length. Okay. Third one. Write down the type of stress. What is the type of stress? Compressive stress, because length decreasing. Compressive force. Compressive stress. Compressive stress. Compressive stress. Fourth one. What is the stress? Stress equal perpendicular force over cross section area, not the full cylinder area, not the beam area, cross section area, because the force apply on the cross section. Force apply on the cross section. Okay, now what is the perpendicular force? The diagram given, the force system, the 15,000 Newton is, it has elevation 30-degree angle. Okay, how to calculate the perpendicular force? You can resolve this force into perpendicular direction like this. Okay, how to resolve it? Sine or cos 15,000 sine 30, because we are not going to resolve it into angle direction, into opposite direction we are resolved. This 30 is there. Then it is 15,000 sine 30 over, how to get the cross section area? Now what is the shape of the cross section? It's a circle, no? The cross section is a circle. How to get the circle area? 5r square. 5r square. 5r square. 5 r, what is the radius? 20 centimeters. 20 centimeters you can convert into meters. 0.2. 0.2 into 0.2. This is the answer. Okay, 15,000 sine 30 means 7,500, because sine 30 half. 7,500. 7,500 over 5 into 0.2 into 0.2. 0.2 into 0.2. 0.04. 0.04 into 0.2 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 into 0 It is 0.126 approximately. 0.126. Now you can divide 7,500 over 0.126. 7,500 over 0.126. 59,000. 59,523.8 Na minus 2. 59,523.8 Pascal. Okay, this is the stress act on the beam. It's a huge stress. Huge stress because 15,000 Newton force on a small beam. Understood? Are you correct this one? You met? Good. You correct? Sadev? Sadev correct? You Afsar? Area calculating unit row. You used 20 centimeter. Yeah, 20 you can't use. 20 use karo, the area, the stress coming Newton centimeter square. This is not the Pascal. That's wrong. Mariam? Correct this. Always stress equal perpendicular force over cross section area. Remember, the perpendicular force over perpendicular force acting area. That means cross section. That can be cross section. Perpendicular force, if they give an angular force, you have to resolve it into perpendicular direction and get the area in square meters. That's very important. Square meters. Okay. 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 This is a basic part of the lesson. Actually, first part of the lesson. Okay. Let's move into our second part of the lesson. Second part of the lesson. Come to page number 3. No, 4. Okay. Okay. Now, okay. This is the second part. Now we are going to discuss relationship between this basic fundamental concept. Okay, first we discuss fundamental concept. What are the extension, strain, and stress? Okay, now in Tude given the strain and stress relationship. Okay, before that, let's discuss about the relationship between the relationship between the relationship between extension and applied force in very simply level and applied force. Okay, take a paper and write down this topic, and you can attach this paper into your tute. The same thing even in the tute. Before that, I'm explaining very simple level this experiment. Okay, now this is a very simple experiment. Okay, now I'm going to conduct very simple experiment. Okay, think it is a rubber string. I'm going to connect this string into a whatever fixed surface. Think it is a rubber string. Oh, sorry, this is a rubber string, and I'm going to connect this rubber string with a plate. මෙතනට අපි cup එකක් වගේ set කරගත්තා. හරිද? Like a plate. And we can get a meter ruler for measure the length. We need meter ruler. Okay, this is experiment. Hari? Okay, this is experiment. Okay, now I'm going to increase the force. How to increase force? I'm think we can get additional bar. 1 kilogram, 2 kilogram, 3 kilogram, 4 kilogram, 5 kilogram, 6 kilogram. හරිද? මෙහෙම bars ටිකක් ගන්න පුළුවන්. Extra bars. Okay. Now we can prepare a table like this. Okay, this is applied force. This is applied force, and this is the extension. This is extension. Okay, think applied force and extension. Think when I apply 1 kilogram substance into this plate, what happened? What is the applied force on the string? What is the applied force on the string? 1 Newton, right? Because 1 kilogram, sorry, 10 Newton. 10 Newton. 10 Newton. Okay, now 10 Newton applied on the object. 10 Newton applied on the object. What is the extension? Remember the extension was 20, not 20, 0. I'm going to get in centimeters for easy understand. Extension 2 centimeter. 2 centimeter. Example, okay. 10 Newton, because 1 kilogram is 10 Newton. The extension 2 centimeter. The length of the string increased by 2 centimeter. Understood? We can get the increase in length by meter rule. I got the practical. Simple practical. Understood? Mariam? Okay, this is a rubber string and they are the fixed mass substance. Okay, now what I'm going to do, add one by one this substance into plate and measure the extension, measure the increase in length. Okay, second term I am going to add 2 kilogram substance. 2 kilogram means 20 Newton. How about the extension? Remember, 4 centimeter is the extension. The length increasing by 4 centimeter. 4 centimeter. That means another 2 centimeter. Then කොහොමත් 2 වැඩි වෙලා තියෙන. තව 1 kilogram දැම්මම increase by another 2 centimeter. The total extension 4 centimeters. Total extension 4 centimeters. 4 centimeters. Okay, I'm going to add third substance. 30 Newton. Increase up to 6 centimeter. 6 centimeter. 6 centimeters. 6 centimeters. Okay, I'm going to add 40 Newton. That means 4 kilogram substance. It's increased up to 8 centimeters. 8 centimeters. Now it has in initial length, think it is initial length 50 centimeter. Now it has increased up to 58 centimeters. 58 centimeter. 58 centimeter. Now the this string has huge stress because due to high external force, 40 Newton external force, 4 kilogram applied on the object. Now, if I add 50 Newton, 5 kilogram substance into the plate, remember, the stress increasing by up to 11 Newton. 11 Newton. Now you can see it is increasing by 3 centimeters. 3 centimeters, sorry. 11 centimeter. Okay, if it is at 60 Newton, think it is increased up to 15 centimeter. 15 centimeters. Finally, if you add 77 kilogram, think it is increase up to 20 centimeter and break down on this point. Breaking mean make a break. The string will be break at this temperature, at this mass, at this force. The string will be break down. Okay, now if I got this experiment data, experiment result into a graph, if I got this experiment result into a graph, let's see what happened. What's the shape of this graph? Okay, this is the extension. Always remember this type experiment. When we prepare graph for this type experimental result, always x-axis always x-axis, increasing length, increasing data. Okay, what we increasing here? External force is increasing, right? External force is increasing. Extension changing. Extension changing. අපි වැඩි කරන එක තමයි අපි change කරන එක තමයි x axis එකට එන්න ඕන. Always that we call as independent factor. Independent factor. This is a dependent factor. According to this factor, this depend on the always changing factor is the x axis. Okay, that we can discuss in the future practicals. All right. Okay, now think it is applied force 10, 20, 30, 40, 50, 60, 70. Now extension 2, 4, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 centimeters. Extension and applied force. Okay, now let's draw the graph of this shape, of the graph. 10 Newton, what is extension? 2 centimeter. 20 Newton, 4 centimeter. 30 Newton, 6 centimeter. 30 Newton, 6 centimeter. 40 Newton, 8 centimeters. 8 centimeters. 50 Newton, 11 centimeter. 50 Newton, 11 centimeter. Not this. 11 centimeter. 60 Newton, 15 centimeter. 15 centimeter. 15 centimeter. 70 Newton, 20 centimeter. Okay. Now, can you understand the shape of this graph? Shape of this graph. Okay, this is a shape. Up to this level, up to 40 Newton, it is a straight line. It's a straight line. But after this straight line, it's going in a different shape. It's going in a different shape. Okay, this is the shape of the graph. This is the shape of the graph. Okay, actually, this is the actual scenario. I will show you. Wait. Okay, now this is a actual scenario. Now this is a rubber string. Now I am going to increase the applied force. Increase the applied force. Okay, now I am going to increase the applied force. Okay, think 1 Newton, 2 Newton, 3 Newton, 4 Newton, 6 Newton, 7 Newton. Now think what happened to the thickness of the string? Now thickness is very low, very thin now, very thin. Okay, if I increase the external force again and again, what happened? At a certain level, the extension increase in considerable level, and it after certain external force, it will be breakdown. It will be breakdown. The same story. Okay, therefore that the final point we called as a breaking point. Breaking point. Breaking point. Breaking point. Okay, that is the actual scenario when we apply external force on any elastic object. That's the actual scenario. For elastic object only. For elastic object, that's the shape of the graph. That's the shape of the graph. Okay. Now, can you see the first 4 phase? That means 0 Newton to 40 Newton. How about the extension is vary in a straight path? In a straight path. Therefore, we call this path is proportional range. Proportional range mean when increase the external force, the extension increase by directly proportional way. That's why we call as it is proportional range. Remember the name. The straight line path we called as proportional range. Proportional range. Proportional range. Proportional range. Proportional range. Now, this point, 50 Newton point, as example, 50 Newton point, you can see it's not proportional. It's still not proportional. But remember that we called as elastic point. Elastic point, I will explain in the next graph. Elastic point. That's the example, elastic point. Elastic point. Remember this initial point to this, think it is a this is O. For understand, make up in a label. Think it is O point, A point, B point, C point, and D point. D is the breaking point. D is a breaking point, the point where the string will break down. Okay, that's a breaking point. Okay, think the B is the elastic limit. What is the O to A? O to A we called as OA range, proportional range. A point is a proportional limit. Proportional limit. Proportional limit. Proportional limit. It's proportional limit. Proportional limit. Proportional limit. Proportional limit. Proportional limit. Okay, you can note down these terms. In next graph, I will explain the full story. That's an example. Okay, that one also not elastic point. Elastic limit. Elastic limit. Elastic limit. Elastic limit. Okay, if you got the O to B point, the full range that we called as elastic range, up to elastic limit, the full range we called as O to B, that's the elastic range. What is the elastic range? Elastic range. Elastic range. Elastic range. Elastic range. Elastic range. The C point we called as, think it is C, D, and E. This is the D, and this is the E. Okay, C point special case. C after B point, it don't have elastic characteristics. We call the up to B is the maximum elastic limit. I will explain one by one again. Now just understand, make elastic properties only for B points. B point, only up to B point. After B point, it has plasticity characteristics. Plasticity characteristic mean when we apply external force on the object, it's not again return to original position. It's not original. Therefore, the C point we called as yielding point. Yielding point. It has very small deformation. At C point, the object has small deformation. Small deformation. Okay, remember this is the yielding point. Yielding point. Yielding point. Yielding point. Yielding point. Okay, the D we called as a breaking stress. At D point, it's permanently deforming. That means the thickness is very low. That's a D stage. That's the D stage that we call as breaking stress. Now it is very close to breakdown. I got that we called as breaking stress. Breaking stress. Breaking stress. Breaking stress. Okay, they are the steps follow when we apply external force on an elastic object. They are the stages that object undergoing stages. Okay, are you clear? I think you got very simple idea. මේවා අපි ආයි කතා කරනවා next graph එකේ. Okay, please note down this experiment and graph and the and table and graph and label these terms. Okay, next I will explain our actual experiment. Okay, complete. Okay. Okay, this is the proportional range. This is the elastic range up to B. This is a proportional limit. The B is the elastic limit. The C is the yielding point. This is the breaking stress. The final point is the breaking point. Breaking point. Okay, next thing. Okay, the same experiment, the same type experiment done by a scientist called as Hooks. Hooks කියලා scientist කෙනෙක් ඉන්නවා. හරිද? He found the relationship between, same as this experiment, he found the relationship between strain and stress. They got x-axis and strain and y-axis stress. Okay. Okay, this is the given in the tube. The graph was this shape. This is a shape. The same type experiment done by scientists as called as Hooke. එයා කරපු experiment එකේ this is the result that's given in the tube. This is the result. Same type experiment done by the scientist. This is the strain. Strain mean what? The extension over initial length. Extension over initial length. This is a stress. Stress mean stress. Stress. Applied force over cross section area. Okay, according to this graph, the same theory. Okay, this is the shape of this graph. This is the shape of this graph. Up to certain height, when increase the stress, the strain also increase. Strain and stress both increasing in proportional way, directly proportional way. After this point, it's vary. The shape vary. And finally, it's come to breaking point. Okay, this is a shape. Remember this shape. Okay, that is for elastic objects, not for inelastic objects. For elastic object, think it is O. This is a A. This is a labeling for our understand. Okay, this is a shape normal. B, and this is a C. So this is the, according to Tute, it is E. E mean elastic range. This is a B. This is a C, and this is a D. Okay, now understand, in the first range, it's increasing in proportional way. Therefore, the A point we called as the proportional limit. Same as previous example, the A point we called as proportional limit. A point we called as proportional limit. Proportional limit. What's the meaning? In this up to this proportional limit, when we increase the external force, the extension increasing in same range. Like our previous experiment, 10, 20. If we increase up to 20, it's increased 2 by 2 by 2. Okay, in same range. That's called as proportional range. Up to A point, when increase external force, the extension increase in same range. This range we called as proportional range. Remember the name, proportional range. That's very important. All our calculations doing in this range, proportional range. Okay, after A point, no any proportional characteristic, no any proportional limit, but remember A to E. Now O to A, it has elastic characteristic. That means again returns to the original position. And it's proportional up to O to A. But after A point, no any proportional characteristic. Remember, but still the object has elastic characteristics. After proportional range, also it has, in a very small range, it has elasticity characteristic. Therefore, E mean O to E, remember, that is the elasticity limit. Up to E point, it's again returned to the original position. Understood? Up to E point, it's again returns to the original position. No any deformation, no any permanent deformation. I got Dinul? no any permanent deformation. But after a point, no any proportional. Okay, proportional is different. Proportional range is different. Proportional range vary, and up to E point, it has elastic characteristic. Elastic characteristic means when it is release external force, again it's come to return force. No any permanent increase in length. Okay, no any permanent deformation. Again, it's returned to original position. That's the second point. Okay, that we call the E point is a elastic limit. E point is a elastic limit. Elastic limit. Elastic limit. O to E we called as elasticity range or elastic range. Elasticity range. O to E we called as elasticity range. O to E. Make mandana because it will be unclear. Okay, let's do like this. A to E. Okay, up to this level, it is elastic range. Elastic range. Elastic range. The E point is the elastic limit. That's the maximum point. O to E, it has elastic properties. Elastic properties mean when it is released, it's come to its original position, original shape. Original shape. But O to A, it has elastic property as well as proportional characteristics. Proportional characteristics. O to A, but after A point, it has only elasticity characteristics only until E point. Sandit understood? Sadhu? That's very important because after that we have Hooke's law. The Hooke's law he explained about related to this graph. Understood? Up to E point. Okay. Now, okay, the B point we called as a yielding point. At B point, yielding point, yielding point, yielding point, yielding point. Okay, yielding point mean think this is a string. This is a string now. Okay. Now when we apply external force, now this is a string original length. When we apply external force, it's increase up to this level. Haridha? Increase up to this level. Think increase up to this level. But if I release, oh sorry, when I release this, when this external force release, again it's not come to original position, original length. If it is come to original length, this is original length. But it has very small deformation that we called as yielding stage. Yielding stage. Method that has a very small yielding point. It's a very little amount that we called as very little deformation, permanent deformation. That's we called as a yielding stage. When we now what we doing, we increase the strain. Increase the strain mean increase the stress, no? Increase the stress and measure the strain. Okay, now after B point, it has large permanent deformation, considerable. See, after C point, rapidly length increasing, rapidly increasing. That means it has a considerable permanent deformation. Okay, that's why we called as the C is the breaking stress. Breaking stress. Breaking stress. The C is the breaking stress. Breaking stress at this time, at this breaking stress, okay, this is a breaking stress. The thickness is very low and it is highly deformation in a large amount. After that, increase the external force, it will be breakdown like this. Okay, this is the meaning of breaking stress. That we call as breaking stress. Breaking stress. Breaking stress. This is the breaking point. At this point, it will be breakdown. Breaking stress. Breaking stress. Sorry, breaking point. Breaking point. Okay, that's the story. Can you understand? Any doubt you can ask now. Any unclear point you can ask. Okay, go to next. Go to tut. It's clearly given. Any doubt? Okay, this is a graph. Okay, this is a graph. This is a strain. This is a stress. This is a strain and this is a stress. O to A point we called as elasticity range. Elasticity range. O to A. O to A is not given. Sorry, O to A proportional limit. The A point is a proportional limit. Understood? O to A is a proportional limit and O to A range is a proportional range. ID is not given. You can write down. O to A we called as proportional range. O to A proportional range. Proportional range. Proportional range. A point is the proportional limit. That's the maximum point of the proportional range. A point is a proportional limit. A point is a proportional limit. E is the elastic limit. That's the maximum point of elasticity range. Elasticity range. Elastic range, maximum point. E point is the elastic limit. Elastic limit. Okay, after that, B is the yielding point. At this point, has a very small, little permanent deformation. Remember, after E point, it don't have elastic properties. It's work as a plasticity object. It's not again returned to the original position. Okay, the A is after A point don't have proportional characteristic, but still until E point it has elastic properties. It has elastic properties, but after E point don't have any elastic characteristics. Okay, the B is the yielding point. The B is the yielding point. Yielding point. It has very little permanent deformation. Okay, you can see C. When it is come to C, it's a considerable change. Considerable change. Therefore, C we called as BC. See, BC we called as plastic deformation. Plastic deformation means again not come to the that's permanent deformation. Permanent deformation. After C point, sorry, after B point, after yielding point, it has a plasticity deformation. ගොඩක් දිගින් වැඩි වෙනවා කියන එක. Plasticity deformation or plastic deformation. Okay, C is the breaking stress. I explained. C is the breaking stress, and OE. OE is the plastic deformation. See, I told plastic range. Sorry, elastic range, elastic deformation. OE. Understand? OE up to this level that I explained over. OE. The breaking point is a D. I got. Okay, that's the full story of the Hooke's experiment. Okay, please understand what's the meaning of plastic deformation and what's the meaning of elastic deformation. Elastic deformation means when it is released, again come to original shape. Plastic deformation means after B point up to Up to after E point, no any elastic deformation. Up to E to B, remember it's deform very little amount, permanent deform. But B to C, it's a considerable plastic deformation. That's why we call BC is a plastic deformation. Okay, go to next page. Okay, the full explanation given here. O to A is the proportional range, correct? Proportional range. Okay, the same thing, Maria. The same thing given in the tube. Okay. Okay, O to A is the proportional range. In the proportional range, yes, this is the meaning. Stress directly proportional to the in Hooke's law. I will explain. Stress directly proportional to the strain. That's the meaning. It's just shape is straight line. The A is the proportional limit, the maximum limit of the proportional range. A to E is the elastic range. Yes, that I explained. Stress and strain not proportional. Remember, stress and strain not proportional at this range. But material returns to original shape when it is unloaded. Still showing elastic properties until E point, elastic point. E is the elastic limit. E is the elastic limit. Yielding point, B. Material brings to deform plastically with little increase in stress. Yeah, very little amount. Remember, at the yielding point, it is very little amount. Plastically deform, very little amount. Okay, B to C, after B point, after yielding point, large permanent deformation occurs. It's a considerable deformation, permanent deformation. Okay, after C point, that means break in stress, the cross section area reduce. That we call as necking. Necking can the thickness of the string become very thin. That means it is very close to breakdown. Very close to breakdown. Cross section area reduce and breaking point is a D. Yeah, the C is the breaking stress is indicates unlimited tension state. That means that's a maximum. Okay, when it is past the unlimited maximum range, ultimate range, what happen? It will be breakdown after past the C point. Okay, that's the story. Okay, any doubt up to now? That's very important. No. Okay. Okay, let's move into Hooke's law. Now, I told the previous experiment done by the scientist named Hooke. Now, the next one, the next topic, Hooke's law. We are going to discuss what is the concept he has explained. Okay, the scientist explained according to his previous experiment, he found there is a straight line region A to B, no A to B, O to A, O to A, that's a proportional range. He found within the proportional range, actually proportional range, strain directly proportional to the stress. That's the Hooke's law. Very simple. Within the proportional range, O to A range, strain directly proportional to the stress. That's a Hooke's law. Within, but only for within proportional range. After past proportional range, when it is passed in the proportional range, it's not directly proportional. He explained within the proportional range, actual proportional range can directly proportional can within the proportional range, strain directly proportional to the stress. Strain directly proportional to the stress. Strain directly proportional to the stress. And he found within this range, strain directly proportional to the stress mean. Okay, what's the meaning of strain? Strain mean E over L1. E over L1 directly proportional to the stress. Stress mean F over A. F over A. Okay, this is actually Hooke's law. Hooke's law. But he found this initial length and cross section area, they are non-changing factors. They are fixed factors. Now, if you got this string, its initial length and extension fixed factors. No, they are not changing. Therefore, he found if it is stress directly proportional to the strain, the actual thing, the applied force also directly proportional to the extension. Applied force directly proportional to the extension. According to this concept, he found equation F to remove this proportional mark. He used constant. The constant for this experiment, it is K. Now K we called as a elastic coefficient or spring constant. This is K. Elastic constant or spring constant. Okay, that is our basic equation of the Hooke's law. According to Hooke's law, he explained within the proportional limit. Within the proportional limit means straight line region. Within the proportional limit O to E, he explained applied force directly proportional to the extension. Now, to remove this proportional mark, we can use equal constant E. The F equal KE is the topic. F equal KE. What is a K? The K is spring constant. Okay, what is the unit of the K now? What's the unit of the spring constant? Now you can isolate the K. K equal F over E. What's the unit of the K? Nm minus 1. Newtons per meter. Newtons per meter is the K, spring constant unit. Okay, understood? Very simple. Okay, this is a proportional range. This is actually experiment. He got the meter ruler and this is experiment. Okay. Okay, understood up to now? Sandit? Sadev? Hari. Okay, let's move into the final part of the lesson. Today we can complete the lesson theory part. Okay. Okay. Now, okay, what is the now according to Hooke's law, in the proportional range, the stress, sorry, applied force proportional to the directly proportional to the extension. Okay, unbalanced force directly proportional to the extension. As well as previously you told, according to Hooke's law, in Hooke's law, according to Hooke's law, in the proportional limit, in the proportional limit or proportional range, up to proportional limit, in the proportional range, the stress directly proportional to the strain, right? Stress directly proportional to the strain. That's a first observation of the scientist. Strain. Okay, now we can solve this observation and we can get another equation. But okay, what does the stress mean? F over A, F over A directly proportional to the strain. Strain mean E over L1, E over L1, E over L1, E over L1. Okay, now F over A directly proportional to the, now it is directly proportional. Okay, I want to remove this proportional mark. What I can do? We can use a constant. Remember, for this stress and strain relationship, our constant is y. This y we called as Young's module. The y is the Young's module. Understood? That's the meaning of Young's module. Young's module. Young's module. This is a symbol. This is a symbol. Hard. Okay, this is actual relationship. According to Hooke's law, stress directly proportional to the stress directly proportional to strain. Now we can get stress over, sorry, stress Young's module, sorry, the stress directly proportional to strain. To remove this proportional mark, I use constant, the Young's module. Y is the symbol. Y is the symbol. Hard. Now I told previously spring constant. Previously spring constant. This one, that one also constant, depend on the material type. Depend on the material type. That means rubber, it has a one value. Plastic, it has a one value. Wood, it has another value. Okay, therefore copper, it has another value. Aluminium, another value. Okay, material to material, the spring constant, K value is changing. K value is changing. Samely, material to material, Young's module also changing. Okay, I have given in the tute examples for Young's module. See, steel Young's module given, copper, brass, aluminium, glass, material to material, the Young's module value will be changing. That's why we call they are constant, depend on the material type. They are constant, depend on the material type. Okay, Young's module. Okay, can you get the unit of the Young's module? It's a good activity. Now our equation F over A equal Young's module into E over L1. Now you can you calculate the unit of the Young's module, Y unit? Okay, you can calculate. I need to find the unit of the Young's module. Okay, what's the unit? Yumit, Vihenga? What's the unit of the Young's module? The Nickment. Okay, if we isolate the Young's module, what is the equation? If you isolate the Young's module, very good. Vihenga, what's that? What's the unit? Okay, no. It has a unit. Okay, Mabala, very simple. The Young's module we can modify. අපිට ඕන මෙහෙමත් කියන්න පුළුවන්. Okay, if I isolate Young's module, very simple, very important part. If we can isolate the Young's module, okay, now it is multiplication. Now f over a divide by e over L1, right? E over L1. Okay, what is this? What is this? F over a mean then may part එකම ගෙන්නලා divide කරා. Okay, that's the easy method. We have understood. Sadev, that's a Young's module. F over a divided by e over L1. Correct? මේක තේරුණාද? Mariam? Okay, then what is this? F over a mean F over a කියන්නේ stress. E over L1 mean strain. Remember, we can modify this Young's module. Young's module mean the ratio between stress and strain. The ratio between stress and stress. Stress divided by strain. Remember, that's the actual theory, but we can modify this equation. Young's module equal stress over strain. Okay, now Young's module, you know, stress unit Nm minus 2, it's no units. Then what is the Young's module unit? Young's module unit same as stress unit. Pascal. Yeah, stress over strain, good. Stress over strain. Yes, stress Nm minus 2 Pascal, strain no units. The Young's module unit Nm minus 2. Okay, go to Tut. Then මෙතන දීලා තියෙනවා the unit Nm minus 2. Young's module. Okay, see, this is Young's module. Since the strain is a ratio of similar measurement, it has no unit. Yes, strain no units. The ratio of tensile strength, stress and strain is called as a Young's module. එහෙමත් අපිට කියන්න පුළුවන්. The ratio of tensile stress to tensile strain or compressive stress to compressive strain called as Young's module of material of the wire. Young's module equal stress over strain. Don't think about this tensile, it can be tensile or compressive. Okay, that's a symbol of Young's module. Y is a Young's module. Okay, this is the equation. F over a divided by, that means stress over strain. Stress over strain. Stress over strain. Stress over strain. This is a unit of Young's module. It's Pascal. Okay. Okay, that's a basic concept of the basic theory part of the uh, Young's module. We have another practical. Young's module practical and equations ටිකක් විතරයි තියෙන්නේ. Okay, now you can discuss, you can complete the tutorial. Now you can complete, yes. Yeah, up to this level. Without this question, without this final question, without without this question, මේකත් පුළුවන් ටික කරන්න ඔයාලා try කරන්න. Without this question, other questions you can try. MCQ questions. Yeah, all MCQ questions now you can complete. Yeah. Yes, we have another practical. Up make a practical like karama. We can discuss this question. Let's say A-level question. A-level question. Okay, next week we can discuss the practical, and in the practical sessions also again we are discussing the same practical. That's a practical given in our practical book, not our syllabus. Okay, that's all about elasticity. Very simple lesson. Okay, your homework, complete the MCQ tutorial questions. Okay, any doubt? Today lesson? Today, very important part we discussed. It is very simple, but if you not understood, if you not catch up well, the simple theory, it will be very difficult to advance, difficult to understand. Again, it is very difficult. You have to understand the basic concept, then you can understand after reading anything. Hari, understood? Okay, complete the homework, MCQ questions, and if you want, you can try, but it's not compulsory. If you can try this. Yeah, first parts you can complete. First part මෙතනට එනකම් පුළුවන්. Okay, you can try. MCQ all questions you can complete. Okay, you met? Okay, Sadev, understood? Okay. Okay, we can discuss next week practical and questions. That's the end of. Within this month, we can complete the elasticity lesson. Next week, we can, next month, what is the today, 22? Next week, March, 1st of March. Okay, no issue. Within next week, you can complete the lesson. Second week, we can start the new lesson. Okay, and now new students, you can inform about our class. Now, the 2028 students, we are starting from 5th of March, new classes for new batch 2028. Okay, goodbye.